In the next several videos, we're going to apply what we've learned in the class to an analysis of various features of Java. This will give us a chance to both look at a real programming language and how its design has been done, and also to talk about some features that aren't in cool and that we haven't been able to cover thus far in the course. From the perspective of this class, Java is a kind of cool on steroids. It's cool plus more features, many more features. At their core, Java and Cool are very similar. Java and Cool are both typed, object-oriented, garbage-collected languages. They were both designed in the early 1990s, and so they share a common culture there with the ideas that were current at that time. So in this video, I'm just going to give a little bit of the history of Java. So that'll be the focus, really, of this rather short video. And then in the subsequent videos, we'll talk about all the features or some of the features of Java that are not in Cool. And we'll use the ideas, of course, that we've been discussing all along through the class to explain a little bit about those ideas. But I think these are all important language constructs that unfortunately were too time-consuming or too complicated to add to the course project. And so I think it's useful to use a language like Java to illustrate how these ideas work and what some of the issues are. So Java began as a project called Oak at Sun Microsystems, and it was originally targeted at set-top devices. And so what was a set-top device? This was a little box that was going to sit on top of your TV, so you had your TV screen, and then there was going to be this little thing up here that was going to sit on top of the TV, and it was going to control all your cable programming. So this would essentially connect to some kind of a network, and it would help you to do, to make your TV more interactive. Okay, so this is back in the days before every TV was really a computer by itself. And the initial development of Oak took several years. I believe the project ran from about 91 to 94. And what happened, at least as I understand it, is that the set-top device market just never took off. So this never really became a popular, never became a popular idea with consumers. And so there really was a kind of limited upside or a limited potential for Oak at the time. And then something happened. The internet happened. So also in the early 90s, the internet revolution was really gathering steam. Everybody was getting on the internet. And it became obvious sometime 93, 94 that there was going to be a need for programming languages that really addressed the specific issues on the internet. And in particular, people were very concerned about security, and they didn't want to be downloading lots of binaries that were from programs written in C and passing those around on the internet, because there was just really no guarantee that those programs would work as intended and not crash your machine. So the need to be able to share code over the internet from other people that you didn't necessarily trust completely meant that we needed safer languages than languages like C and C++. And so there was an opportunity there for a new language. And there were several candidates, actually. Besides Java, Tcl and Python were very serious candidates to become the internet programming language. And eventually, the backing of Sun Microsystems, the backing that Sun gave to Java, helped it to really gain a very, very strong presence on the internet. But the point of this story is that every new language needs a killer app. Every programming language rides into the world on the back of some application. So there has to be some kind of new application that people want to write that the existing languages don't serve very well, and that provides the opportunity and that makes it worthwhile for people to learn a new programming language. And so the fact that Java was a very safe language, it had the garbage collection, it had the type system, that made it well suited at the time to the needs of the emerging needs of internet programming, and it became very popular, I think, primarily because of that reason. And if you recall, there was a lecture or a video early on the economy of programming languages, and I would recommend actually that if you haven't watched that one, that you go back and take a look, because there I discuss some of these ideas about how languages are adopted in more detail. So Java also came into existence in a particular technical environment, and it's very common. In fact, it's normal for new programming languages to borrow heavily from their predecessors. And new languages are often mostly recombinations of ideas from previous languages in a new design, perhaps with some innovations thrown in. And the particular influences on Java, again, this is at least as so far as I understand it. So the type system in Java, or its commitment to types, probably is traceable to Module 3. And the idea is there where people try to build a programming language that would scale in a realistic way to large systems, but also be strongly typed. The object orientation of Java, traceable to languages like Objective-C and C++, and also Eiffel, which also had the idea of interfaces, which is a prominent feature in Java. And finally, Java is quite a dynamic language, meaning that there are many things that are not done statically, they're done dynamically. So features like reflection would be one example of that, and there are actually quite a few other features. And there's some history there, there's some shared culture there with Lisp, which was is a functional family language, but is also a very, very dynamic language. As I said at the beginning, this video is just an introduction and overview, and in the next few videos we'll be looking at specific features of Java and how they work, and that will include things like exceptions, interfaces, and threads, as well as a bunch of other features that we'll discuss at least briefly. One thing to realize is that Java is a big language. It is not simple. The language manual for Java runs to hundreds and hundreds of pages. It has lots of features, and perhaps more importantly, lots of feature interactions. So the hard part of designing a language, of course, is getting all the feature interactions right, all the combinations of the features, and making sure there are no surprising interactions between them.